Okay, a similar question with a boat and a current. So a boat travels at an average speed of 15 kilometers an hour in still water. Okay, it's a little bit more tricky to figure out how fast your boat's going. The boat travels 12 kilometers downstream in the same time it takes to travel 8 kilometers upstream. Find the average speed of the current. And state your variables, show all your work. Okay, so if you're driving, driving your boat in a stream, you can tell, you know that the current is going to push you one direction or the other. So if you're paddling your canoe upstream, the current is working against you. And if you're paddling your canoe downstream, it's working for you. So let's just draw a quick little diagram to keep track of our scenario here. So traveled downstream, it went 12 kilometers downstream. Okay, that's the distance. 12 kilometers downstream, and it took the same time as going 8 kilometers upstream. Okay, so these two things took the same time. How fast is the boat going? It's going 15 kilometers an hour in still water. How fast is it going downstream? Is it going 15 or is it going faster? Faster. How much faster?
27 kilometers. Oh, wait, 12.
Do you know?
No.
Is that what you're trying to find out? Yeah, you're trying to find out the speed of the current. So how about this? We let C equal the speed of the current. Okay, so then how fast is it going downstream? 15 kilometers an hour, the speed of the motor, plus C, the speed of the current. You tell me how fast it's going upstream. The motor's pushing it at 15 kilometers an hour, and the current is working against you. Let's say that again. Okay. Can you set up an equation? So let's read through the problem again, because we kind of kept track of everything. We're letting C equal the speed of the current, and our boat travels at an average speed of 15 kilometers an hour in still water. Okay, so that's the work the motor is doing. It travels 12 kilometers downstream in the same time as it takes to travel 8 kilometers upstream. How do we write time? Well, time is distance over speed. So this time to go down is going to be the same as the time it takes to come back up. How do I write an equation for the time it takes to go down? The distance I traveled downstream divided by the speed at which I traveled. That's going to be equal to the time it took to come upstream. How far did I travel upstream? 8 kilometers over 15 minus C. Okay, so the time to come upstream is distance over speed. Distance over speed. Okay, after this it's easy. Do you understand the setup?
Yeah.
Okay, solve it. Y'all getting 3? So the speed of the current is 3 kilometers per hour. Got a question for you. How fast did you travel downstream? What about upstream? So going down, I guess you're going 18 kilometers per hour. And coming up, 15 minus 3, you're going 12 kilometers per hour, which means you didn't get as far. If you want to get back to the starting point, it's going to take you a lot longer, which could be another question. How long would it take for you to return back to your starting point? I'll leave